Hey, what's up? It's your old pal, Mr. Cook, and we're going to start working on simplifying rationals from a 3.1. The whole section, or the whole chapter on 3 is going to be on rational functions, which are just polynomials over other polynomials. So we're going to be using the same rules that we did for polynomials. The same key rule is going to apply here, and that's that you need to factor first. Make sure to factor, okay? Very, very important to do this. If you don't remember how to factor, if you need some refreshers on factoring, you know that there are some worksheets that you can work on, from your teachers. And then also there are videos that I have on this YouTube channel that focus on factoring. So make sure that you watch those if you need a little refresher on it. All right, so I'm going to do all of the odds on this page, and then we'll move on to 3.2. So first off, simplifying rationals. This is already factored out, so what we're going to attempt to do is just simplify this as much as possible by eliminating common factors from the numerator and denominator. So what that means is just trying to divide out the most you can from the top and the bottom. So if I'm just looking at the numbers here, I just have one big term and then one more big term in the bottom. There's no adding or subtracting or anything like that. So that means that all I can do, to simplify is just simplify the numbers on the top and the bottom and simplify the variables, and that's it. So 24 and 9 are both divisible by 3. If I divide 24 by 3, I get 8. So 8 is in the top, and then if I divide this 9 by 3, I get 3. Since 8 and 3 don't have anything else that they can divide out, I just leave it as is. Next, let's see how many r's we can cancel out from the top and the bottom. So in the top, I've got r times r times r, so 3 r's multiplying. And then r squared means that I have 2 r's multiplying in the bottom. So if I have 2 in the top and 3 in the bottom, 3 in the top and 2 in the bottom, that means I can cancel out at most 2 of them in the top and the bottom, and I'm left with 1 r left over in the top. So my simplified expression is going to be 8r over 3. Now let's find those excluded values. So from the original expression, I just take the denominator, and I just say that that cannot be equal to 0, and then just solve for the r value or whatever variable we have. So if I divide out 9 from both sides, I get r squared cannot be equal to 0, and if I take the square root of both sides, I find out that r cannot be equal to 0. That's the lone excluded values. Okay, next. So now I have 2 terms in the top. So terms are always separated by addition and subtraction. And in the bottom I have 1 term. So if I want to cancel out anything from the top or simplify something out from the top, I also have to do it from the bottom. And it has to be through all 3 of these terms. So what numbers divide out of all 3 of these terms? Well, 27, 27, and 36 are all divisible by 9. So I'm going to divide all those numbers by 9 first. So 27 divided by 9 is 3, so I get a 3x squared minus, and then 36 divided by 9 is 4, so 4x. And then 27 divided by 9 is also 3, so I get a 3x in the bottom there. Next, I notice that each one of the terms has an x in common, and at most 1x, so I'm going to divide out 1x from all of these. So I get, let's see, if I take out one of the x's there, I get 3x to the first power. If I divide out the x here, then it goes away, and I'm just left with minus 4. And then in the bottom, if I divide out the x, I just have a 3 left over. So since 3x, 3, and 4 can't divide anything else out together, that's just my simplified expression. So that gives me, the simplified expression. Now for the excluded values, I just go back to the original function. I take out the denominator, and I say that it cannot be equal to 0, and then solve. So if I divide both sides by 7, I still just get that x cannot be equal to 0. All right, I'll do one more, and then that'll be it for this video, and then I'll move to the second half a little bit later. So, all right, so the top part has 2 terms, and the bottom part has 2 terms. Is there anything I can take out of all 4 of these? No, it doesn't look like it, but I can start taking out stuff from the top and the bottom that's together. So on the top 2 terms, I notice that 10 and 100 are both divisible by 10, so I'm going to divide out a 10. So if I divide out a 10 from the top and not the bottom, I need to leave the 10 and the top. So 10 stays in the top. And then if I divide out a 10 here, I'm left with a squared. If I divide out a 10 here, I get 10a, so plus 10a, all over a plus 10. I also notice that on these 2 terms, I can divide out an a. So I'm going to divide out an a as well. So this becomes 10a on the outside. And if I divide out an a here, I just have a. If I divide an a here, I just have a 10, so plus 10. And then check it out. In the top and the bottom, we have a plus 10. So that means that I can factor out this entire a plus 10 in the top and the bottom. So they just get eliminated, and the only thing that I'm left with is this 10a. So this is my simplified expression. And now let's find the excluded term. So I go to the original denominator, a plus 10, and I say that that cannot be equal to 0. So then to get a by itself, I subtract 10 from both sides, and I get the following. A cannot be equal to negative 10. So there's my excluded values right there. So that's a good place to stop for this one video. I'll finish up the other odds, 7, 9, and 11 in the next video over. That's it.